Today, we are going to start the next unit, which focuses on rational functions. And the first section of this chapter actually focuses on the different types of variations that a function can represent. Now, when we talk about variations, we talk about that there's a relationship within quantities. And today we're going to talk about three different types of variation. We're going to first talk about the difference between direct versus inverse variation, and then we're going to introduce the concept of a combined variation. So the first thing we want to talk about is how to identify direct and inverse variation. And before we can even talk about identifying it, we need to talk about what the exact relationship is. So let's talk about this first, all right? Let's talk about what direct variation is specifically. Now, direct variation specifically is that as one quantity increases and or decreases, the other quantity increases or decreases at the same rate. All right? So essentially this is saying if the quantity of X increases, the quantity of Y increases at exactly the same rate. Or as the quantity of X decreases, the quantity of Y decreases at exactly the same rate. And there is a specific formula used for direct variation, and that's Y equals Kx. Now, K stands as for the constant of variation. Okay? This is the rate at which both the X and the Y increase at, or both the X and the Y decrease at. Now let's talk about how that differs from inverse variation. Now, inverse variation states that as one quantity increases, the other quantity decreases. At the same rate. And essentially, they're inversely proportional. All right, so as X increases, Y decreases at the same rate, or as X decreases, Y increases at the same rate. And it has a specific formula of Y equals K over X, or XY equals K. All right. And once again, K stands for the constant of variation. All right. So the first thing we're going to look at is how to identify it from data. So let's say I gave you the data table X, Y, and I give you 2, 15, 4, 7.5, 10, 3, and 15, 2. Now, the first thing that you should be noticing here is that the x value increases. And then the y value decreases. So we know that this could be possibly inverse. But to tell whether it is inverse, we have to make sure that all of our data points are at the same rate. All right, all of our data points are at the same rate. So if it's possibly inverse, we're going to use this formula xy equals k. So let's see if all of these data points give us the same k value. So 2 times 15, okay, that equals 30. Okay, 4 times 7.5, that equals 30. 10 times 3, well, that equals 30. 15 times 2, well, that equals 30. So we can say because all of them equal the same constant of variation, this is definitely an inverse function. Now, we can also identify that k equals 30. So if you're asked to write the model that represents this function, or the function rule, we know it's y equals k over x, or xy equals k, because it's an inverse function, and we found k. K equals 30. So we could say our function rule is xy equals 30. Or we can say y is equal to 30 over x. Both of these would be the function rule that represents this. All right, so I'd like you to do the next one on your own. Here is our data table. X, y. We have 0.28, 0.520, 1.040, and 1.560. And I would like you to tell me whether it's direct, inverse, or neither. And if it's direct or inverse, to write out the function rule. Go ahead and do that now. So if we checked on this one, we should be noticing that as x increases, y increases. So we know that this could be possibly direct. So now we have to look at the direct function rule, which is y equals kx. So let's see if they all have the same k value from our data points. So 8 is equal to k times 0.2, k equals 40. 20 is equal to k times 0.5, k equals 40. 40 is equal to k times 1.0, k equals 40. 60 equals 1.5k, k equals 40. They all have the same k value, so it was definitely direct variation. All right, and we found the k value to be 40. So our function rule is going to be y equals 40x. All right, so now that we know how to identify from data whether it's direct, inverse, or neither, all right, we need to look at how to solve variation equations. So let's first talk about solving direct and inverse variation functions. And you're going to want to follow these 5 steps when doing this. So for example, step 1, you're going to want to identify what type of variation the problem states and write the generic function rule. So remember, okay, if it's direct, the generic function rule is y is equal to kx. And if it's inverse, the generic function rule is going to be xy equals k. Okay? Once you've written that down, you're going to identify what's been given to you as the known versus the unknown. You're going to use the knowns to find k. Okay? You're going to use the knowns to find k. Once you find k, you're going to write the function rule with the appropriate k value. And now you're going to use the new function rule to find the unknown. So let's look at this first example. Suppose x and y varies inversely and x equals 4 when y equals 12. Find y when x equals 10. So the first thing you have to do is identify what type of variation problem. And it says inversely. So we know that we're going to use the inverse rule. So xy equals k. So that's step 1. Now that we've done that, we need to identify what we know. Well, our known is that x equals 4 when y equals 12. We know that. Our unknown is what y equals when x equals 10. Now that we've identified that, we're going to use the knowns to find k. So we have xy equals k, and we know x equals 4 when y equals 12. So we know k equals 48. So now we're going to write out our function rule with k. xy equals 48. And now we're going to solve our unknown with this new function rule. So we want to find y when x equals 10. Okay, when x equals 10. So 10y equals 48. All right, 10y equals 48. So y is going to equal 48 divided by 10, which we can simplify into 24 over 5. Okay, 24 over 5. All right, so I'd like you to use these steps, all right, to solve the next one on your own. Okay, let's go through this one together. All right, so it says directly. It says directly. So based off of that, all right, we know that we should use, for step 1, y equals kx as our generic function rule. Then step 2, our known related values are x equals 8 when y equals -7. And our unknown pair is what y equals when x equals 2. All right, so then we're going to plug in our knowns to our generic. -7 is equal to k times 8, so k equals -7/8. Okay, so step 4, is we're going to write our function rule now with our k value. And then we're going to plug in our unknown pair to find the unknown. So we get negative 14 over 8, which equals negative 7 over 4. And y equals negative 7 over 4. Excellent. So the last one we need to look at is something known as combined variation. So the last type of variation problems that we're going to look at are combined variation problems, as mentioned. And combined variation problems actually have more than two variables being related to each other. All right, and they could be both related, or all three could be related directly. It could be all three of them are related inversely, or it could be a mixture of both. All right, and so these are examples of what that means. If it says it just varies jointly, okay, if it says it just varies jointly, all right, and there's no other terminology given to you, all right, it means that there is direct variation happening with two other variables. So in this case, z varies jointly with x and y. So z equals k xy. It could say something like z varies jointly with x and y, and it varies inversely with w. All right, so you would have to write a combination of all of those variations. Okay, a third example here is z varies directly with x and inversely with y. So you would have to make a combination of our function rules. So let's look at an example together. Let's say I told you z varies directly with x and inversely with y. Z equals 4 when x equals negative 1 and y equals 2. Find z when x equals 4 and y equals negative 8. Okay, so we're going to follow the same rules. We're going to have to write the generic function rule first. Now it tells us that z varies directly with x. So we know that if that were the case, we would have z is equal to kx. That's the generic direct variation rule. But it also varies inversely with y. So remember, that means you could put it here, or you could put it here. Okay, both mean the same with inverse variation. All right, so step 2 is identify our knowns versus our unknowns. So our knowns is z equals 4 when x equals negative 1 and y equals 2. Our unknowns are we don't know z when x equals 4 and y equals negative 8. So now our goal is to find k using our generic function rule and our known. So we know z equals 4, y equals 2, and x equals negative 1. So if we were to solve for k here, we'd get negative 8. Then we would rewrite our generic function rule with the k value. And now we would solve for our unknown. So negative 8z equals negative 8 times 4. So negative 8z equals negative 32 divide by negative 8, and z will equal positive 4. All right? So in this case, z will equal 4 as well. All right. I'd like you to do one on your own. Z varies jointly with x and y. Z equals 4 when x equals 7 and y equals negative 2. Find z when x equals 2 and y equals negative 3. Go ahead and do that one on your own. All right, so let's go through this one together. All right, so z varies jointly with x and y. So that would be z is equal to kxy. Remember, if it just says jointly, then you know it's direct variation. All right, then we're going to look at our knowns and our unknowns. Our knowns are z equals 4 when x equals 7 and y equals negative 2. And our unknown is we need to find z when x equals 2 and y equals negative 3. So now we're going to find k using our known. And we're going to get k is equal to 4 divided by negative 14, or negative 2/7. Then we're going to plug in that k value into our function rule to solve for the unknowns. So z is equal to negative 2/7 times 2 times negative 3. And we get z is equal to positive 12/7. All right, that is it for today. Have a fabulous day.